Hi everyone, I'm Akash Bijani, and today I'm going to talk about a really interesting case of astronomy misinformation. It's about a cosmic phenomenon called the Pori's Void, something truly massive and mysterious. But here's the thing, a lot of people, including news articles and social media posts, have been showing the wrong image to represent it. And that mix up can really confuse how we understand these incredible parts of the universe. So, over the next few minutes, I'll be explaining what this misinformation is, what the Pori's void actually is, and why the image being used doesn't fit at all. So, let's get started. Here's the misinformation I'm talking about. What you're looking at are two examples of how the Pori's void is being misrepresented. The first is an article from NDTV, a major news outlet, and the second is a post on Facebook. Both claim to show an image of this enormous void, and the way they present it makes it seem like this is an actual photograph of the Pori's void. At first glance, it's easy to see why this might seem believable. The image they have used, a dark, starless path surrounded by bright stars, gives the impression of a vast, empty region of space. It feels mysterious and it fits the narrative of something as incredible as the Pori's void. However, this actually is an image of Barnard 68, which is a dark molecular cloud located within our own galaxy. The two couldn't be more different, but this mistake has been repeated in multiple places, from news articles to social media posts, spreading misinformation about what the Pori's void actually is. Next, we'll explore the differences between cosmic voids and molecular clouds. To start, molecular clouds like Barnard 68 are dense regions of gas and dust found within galaxies, including our Milky Way. These clouds are relatively small and nearby. For example, Barnard 68 is just 500 light years away, practically next door in astronomical terms. What makes molecular clouds like Barnard 68 look like a black hole is that they're so dense that they block the light of stars behind them. It's almost like holding up your hand in front of a flashlight. The light cannot pass through, so you see a dark shadow. This is what's happening with Barnard 68. It's simply blocking starlight, creating the illusion of emptiness. On the other hand, cosmic voids are entirely different. Voids are vast regions in space where very few galaxies exist. They are not made up of material like gas or dust. In fact, they are defined by their emptiness. The Pori's void, for example, is one of the largest known cosmic voids. It's located about 700 million light years away and spans a staggering 330 million light years across. To put that in perspective, the Milky Way galaxy is just about 100,000 light years wide. So the Pori's void is incomprehensibly huge. Unlike molecular clouds, you cannot see a cosmic void directly. Instead, voids like the Pori's void are identified through galaxy distribution maps. Scientists map out the positions of galaxies across the universe and spot regions where galaxies are sparse. That's how voids are detected, through statistical analysis and not through direct images. Now that we've explored the differences between molecular clouds and cosmic voids, here's the evidence that proves that the image used in the article is incorrect. NASA's Astronomy Picture of the Day is a highly trusted resource in astronomy. It features this exact image and correctly identifies it as Barnard 68. It describes Barnard 68 as a dense region of gas and dust that blocks the light from stars behind it, giving it the appearance of a dark patch in the sky. This evidence supports our claim that the image in the article is not the Pori's void, but rather a completely unrelated local phenomenon. In conclusion, this case shows how important accurate representation is in astronomy. When images are taken out of context, it spreads confusion and misrepresents the vast, complex universe we are trying to understand. That's why it's essential to rely on trusted sources like NASA and verify the accuracy of the information we encounter. By doing so, we not only gain a better understanding, but also help ensure the integrity of science communication. Thank you for watching, and I hope this presentation has shown the value of accuracy in astronomy.